Hello, my name is Luis Garcia, and I'll be walking through analysis of the US unemployment from 1967 to 2015. Quick walkthrough of what we're going to be covering. We're going to be covering a basic rundown on the data set and what other features it has in it, an analysis of the time series model to try to see how stationary it is and if there's any indicators of seasonality. And then we're actually going to be analyzing the results of a univariate model and a multivariate model that's going to be including other features that are going to be in the data set. So some information about the data set. The data set covers unemployment rate and other factors from July 1967 to April 2015. And we deem this important information because in those periods, there have been some recessions. And given that people are predicting that we may go into a recession soon, this will be useful to try to predict how much unemployment will come out of these recessions. So the unemployment is going to be the time series that we're going to be analyzing. So from the actual realization that we see, there doesn't seem to be any sort of trend or pattern. Now, there are weird spikes that mess with the constant mean, constant variance assumption for stationarity, but these spikes coincide with recessions, and so we're not actually concerned about them. Now, as for the ACS, that ACF looks very much like what we expect an AR1 model to look like, and it does not differ based on time. So stationarity, we assume based on what we see that this is a stationary model. Now, analyzing the frequencies of this time series, there does not appear to be any very notable peaks in it, except for one at 0. So taking that and the realization and ACF into account, this time series will appear to be very well modeled by an AR1 maybe, or something higher than that, just because there are these very tiny peaks towards the point 1 mark that may be able to alter it. So in trying to find out which model will best represent the time series that we have, I ran the AICs of the top 5 potential models, and the lowest AIC was a 10.56 for an ARMA 4.2 model. And so I will be proceeding. My first univariate model is going to be a ARMA 4.2 model, and analyzing the actual factor form of the ARMA 4.2 model. None of those factors actually seem to resemble anything for a seasonal trend, and thus we will not be experimenting with seasonality for this or differencing, because even though there is a term that could be difference, it is only for the moving average side. It doesn't really affect the AR side, so we will not be proceeding with that. Onto the actual forecast. The forecasts are something that we expected to be off if we were doing long-term forecasts as opposed to very short-term forecasts, just because of that 2008 peak. But we chose to include that peak in one of the estimations just to see how much it would affect the forecast by. And what ended up happening is that when that peak is not included and we're only doing a 1 year, into the future forecast, then the ASE is 26,000, 26,000 for the 1,000 of unemployment. So that'd be 26 million unemployment is the error that we're dealing with. But if we're including the peak, it's 24 million, which in actuality would be errors of 24 billion of unemployment. Just to really hit on how impactful the recession actually is for the unemployment. Now, we wanted to try another univariate model, but this time just completely disregarding any type of moving average effect. And so an AR5 had the lowest AIC of 10.39. Now, this AR5, much similar to the ARMA 4.2 model, did not have any of its actual factor forms resemble a seasonal model, and thus we will not be proceeding once again with any type of seasonality or trying to stationarize the model. Now, as for the actual forecast, Something interesting that did come from this is that the long-term forecast seemed to be around the same range, the 20 millions in error. But as for the short-term ones, instead of 20,000s in the ASEs, we're all the way up to 82,000s. And so from that, it really just depends on which model you would want to use and how far into the future you would want to predict. So for the previous models, we have been assuming that we only know about the unemployment and going from there. For this VAR model, vector autoregressive model, all these variables are going to be mushed together and assumed to be dependent on each other with no actual response variable present. So from this model, we are going to be choosing to do an AR5 because of the var select. Now, the variables included were only the PCE, savings, and the actual population. Median unemployment duration was not included just because it doesn't really seem like how long somebody has been unemployed will affect how many people are unemployed. It seems maybe the other way around. Now, for the actual predictions, much like before, the long-term predictions are going to be doing substantially worse than the short-term predictions. So we have a ASE of 5,675,000 compared to an ASE of 53 million. And once again, this is because it does capture the recession in the middle of it. As for the actual model that I would recommend using, it would be the VAR model, just because whenever the model was created, it was trained with that recession in hand. And though the ASE is significantly higher, it does take into account something that the other models did not. And thus, the VAR model is the one that I would recommend modeling with. So what's next? Next, I'll analyze the data with an MLP model, multi-layer perceptron, which is a bunch of neural networks mushed in together, and an ensemble model, which is going to be taking the results of all these models and getting an average out of it. I will also be exploring how standardizing the data will actually affect the results, just because the variables did have vastly different ranges. But that is it for now. Thank you for your time.